So what this video is going to be looking at is a particular calculation having to do with taking it from a molecule formula unit all the way down to total atoms. So I alluded this, we did a problem like this in class. We did a problem on the other video as well. So I wanted to hit this one more time because this is one calculation that is sometimes misunderstood. So please remember, molecule and formula unit kind of mean the same thing. You have multiple elements bonded together differently. But what we want to talk about, can we break it down into smaller pieces like atoms? So for instance, I have calcium chloride. That is considered a formula unit because it's ionically bonded. So this is calcium chloride. Well, when you look at the formula, realize that I have one calcium, okay, and I have two chlorines. Well, in reality, that's 1 mole of calcium and 2 moles of chlorine. So anytime we're looking at a formula, the numbers you see on the bottom is essentially the moles. That's how everything is broken down to. So I have a total of 3 atoms total when we are talking about this. So I have 1 atom of calcium, I have 2 atoms of chlorine, so they add up to a total of 3. So if I look at bigger molecules, like something like a molecule of glucose, again, it's called a molecule, not a formula unit, it doesn't matter. So I have 6 carbon atoms, I have 12 hydrogen atoms, and I have 6 oxygen. So again, if we are going all the way down to the particle pictures that we were drawing very much so in Unit 1, if I have 1 molecule, which is C6H12O6, I have 6 carbons, 12 hydrogens, 6 oxygens. That means in a molecule, 1 molecule, so again, drawing this out, I would have a total of 24 atoms. I would have a total of 24 atoms. So again, please keep in mind that this is also referenced in your book. Okay, so I'm going to switch over and show you it in the book. So this is found in section 7.1 in your Pearson online textbook. And it's when they started to introduce the moles. So they have a picture of aspirin, which is C9H8O4. So if you have a particle pictures, again, this is how this is an organic molecule, how it's drawn. You have, again, how many black, how many white, how many red spheres do you have? So we could take one of these molecules and break it down into how many atoms we have of each, but also realize that when we're talking about the macro scale, it's essentially I have 9 moles of carbon, 8 moles of hydrogen, 4 moles of oxygen. So for this calculation, we're focused on the atoms. So we're going down to the particle pictures, and you will start to see us have you draw a couple particle pictures with this as well. So from our first example of calcium chloride as a formula unit, I could draw this as a picture. Okay, so if I have a filled in circle for calcium and an open circle for chlorine, this would be essentially a formula unit / molecule of this. But if I were to break it down, again, I would have 1 calcium and I would have 2 chlorines as my total atoms. So what we're going to use this for is some calculations. So once you get it to molecules, how many atoms are you going to have total, or atoms of particular elements? So if we go back to glucose here, I have 6 atoms of carbon in 1 molecule of glucose. So I could say for every 1 molecule of glucose, I have 6 carbon atoms. So that's a relationship that I could use for a series of different calculations. So if I know I have so many molecules, how many atoms of carbon could I look at? Well, I could take 7.8 times 10 to the 23 molecules, and I could put a ratio of, well, how many atoms of carbon is that going to be? Okay, how many atoms of carbon is that going to be? Well, I know for every 1 molecule of glucose, I have a total of 6 atoms of carbon. Okay, So what we're really doing is breaking that molecule up into all of its individual parts. So again, molecule, that's a big number, okay? Please understand that's a big number. But what we're going to do is essentially cross multiply to find my x. So it's going to be 6 times that number of molecules. So I have 4.7 times 10 to the 24th atoms of carbon. Okay. So again, I could take molecules or formula units into a smaller step, which is atoms, okay? And I could do total atoms, so I could do another calculation here, find total atoms. So I could do that in this case. I could take 7.8 times 10 to the 23rd again, molecules of glucose. And what if I want to know total atoms? Okay, so that's going to be my x. So in a molecule of glucose, how many total atoms do I have? Well, back to our breaking it up into multiple pieces, I have a total of 24 atoms. Okay, so all I have to do is multiply those to get that. So I multiply the total molecules by the total atoms, and I get 1.9 essentially times 10 to the 25th total atoms. Okay, so again, this is the breaking down everything to its atoms, the smallest thing.